Hello, this is Tom from anti-proton.com, and I've been asked to explain secondary ionization, specifically in conjunction with criticality events. Yeah, it's kind of a tongue twister. Yeah, sorry about my really crappy cameras. I have like the world's worst cameras. I've got to get this fixed at some point in the future. But anyway, regardless, then I tend to jumble on a little bit, like right now. So yeah, hold on. Let's see here. Okay, you know about alpha radiation, maybe, you know about beta, you know about gamma, hopefully. But what about delta and epsilon? Well, delta radiation is what's called secondary ionization. Basically, what happens is you have a beam of radiation, be it a beam of alpha particles tearing through, or maybe some gamma particles or whatnot. Usually it will be alpha particles, and I can get into the details of that later. But anyway, they impact something else. Neutrons can do it too. They impact something else and knock it off. Think of a billiard ball, like a poker. You know, you're playing poker, and you shoot a ball. Let's say you shoot the cue ball, and the cue ball hits the 8 ball, and the 8 ball goes into the hole, right? Well, the cue ball being hit is your primary radiation. That's your primary ionization. That's sort of wrong. Anybody who has a physics, degree, relax. I know it's not an ionizing event until it actually ionizes something, so just relax. I'm kind of trying to explain here. Anyway, so you hit the cue ball and it ball is rolling. That's, let's say, an alpha particle. Okay, the alpha particle flies over and hits that 8 ball, and that 8 ball is an electron that's orbiting around an atom. Well, it gets knocked away and goes flying off into the corner pocket, and you score, right? Well, that 8 ball just took on the energy from the alpha particle and then went flying off with its own energy. Remember, conservation of momentum, elastic collision, etc., etc., etc. Anyway, it can now fly off and do some damage itself. Now, please understand that secondary ionization is sometimes permanent and sometimes not permanent. When you think of an X-ray tube, in its own way, an X-ray is sort of like secondary ionization. A beam of electrons is being focused against an atom, and it's causing electrons. It's not really secondary ionization exactly, but it's causing electrons to drop all of a sudden to a lower energy state and release a photon of energy. Okay, that photon of energy flying off is now a secondary form of radiation. Now, X-ray is not really secondary ionization. Not really, not exactly, but you get the idea, right? So basically, if you had a really powerful beta emitter, like a really stupid, crazy, powerful beta emitter, and you put it by the right type of metal. Like if you're like, oh, I'm going to protect everything and put it in this little metal shield to hold it. Depending on what type of metal you put it in, it could actually cause additional radiation to come out of it, like X-rays, for example, or even other things. Alpha, gamma, probably just, well, could do alpha, but almost assuredly not. The point is that when you have that much energy flying away from the atom, it can strike and then fly off of something else, and that's called secondary ionization. Now, secondary ionization delta waves, as they're referred to, delta just means change, by the way. It could, technically speaking, be any sort of radiation, although often it's going to be, technically speaking, beta waves. Whenever secondary ionization is beta waves, beta radiation specifically, it is often, it used to be referred to as epsilon radiation. It's not anymore. But the point is, when you have a criticality event, let's say you take a ball of plutonium because you just happen to have a ball of plutonium, and anybody who knows anything about radiation history, nuclear history, probably immediately knows what I'm referring to. This happened to somebody who was maybe, well, let's just say a poor, unfortunate person actually did this. And you put it on a table, a critical mass of plutonium, and then you start putting tungsten carbide beside it, around it. You could also put beryllium. You start shoving the little bricks closer and closer, and it's reflecting the neutrons back into it, causing the critical mass to become, well, a little more critical than it needs to be. And then all of a sudden, boom, you get a flux of neutrons, and these neutrons are flying in every direction, and you run over to a corner somewhere and vomit your guts out. Those neutrons can then go flying and hit other atoms. Now let's say that they hit an atom that is not capable of undergoing fission, and they smack right into an atom. Well, they can increase the energy inside of that atom the increase of the energy inside that atom can make it fly off at an incredibly high rate of speed. Now that's not radiation because that's just a high speed moving atom. But let's say that neutron flies by and dislodges a proton or even an electron. It can do all kinds of crazy things like that. You can have beams of electrons and protons flying off different directions. Protons have a tendency to bounce and recoil like crazy, and they fly all over the place and tear through your body. Likewise, that the neutron could be R captured or S captured into another atom. R captured is rapid capture. Some atoms can absorb a neutron at incredibly high velocities. S capture is a little bit slower. Basically put, that's the way that uranium and stuff usually picks it up. And one of them has to do with weak nuclear force and this interesting probability density that allows for this itty-bitty chance of a neutron gaining entrance into the lower boundary conditions of the waveform that it just, okay, yeah, forget it. I'm getting off topic here, getting into quantum mechanics a little bit. Alright, but just understand the neutrons can fly all over the place and cause all kinds of untold damage. This is kind of a complicated topic that's slightly a little bit above maybe just introductory things. But anyway, so that's basically what secondary ionization is. Anyhow, it can occur with every form of radiation because basically energy is being transported from one object to another object. It becomes secondary ionization when that item becomes ionized and then releases energy. Technically speaking, I wonder if you could consider scintillation as a form of secondary ionization. It's primary ionization. I don't know if that counts as secondary ionization or not. But anyway, the point is, yeah, that's what happens. So that's really all it boils down to. Radiation hits a target, becomes delta radiation in so much as it releases a secondary ionizing radioactive source. Also, some things can actually become permanently radioactive as a result of this. Remember, radiation on an object that's been irradiated can come from either contamination, which can often be cleaned or removed chemically by one means or another, carbonated soda, a little bit of Tide, take it right off, or sometimes you can wait for it to just disappear, like the good old iodine-131 will disappear, like I keep telling everybody, in about 56 days. Or sometimes it can become radioactive. For example, the irradiation of uranium-238 is what produces neptunium-239, which then produces plutonium. So you can the breeder reactors have a tendency to actually make radioactive stuff this way. Like thorium, for example, is turned into uranium-232. I think it's 232 off the top of my head, 233, something like that, as a result of irradiation by neutrons, and that's technically speaking a form of secondary ionization in which a fertile material, fertile meaning that it can capture neutrons and become a different material entirely. It's called a breeder effect, a breeding effect. And a fertile material like uranium, for example, can experience breeding to create a higher, more powerful, and often not so stable material. Kind of interesting stuff when you really think about it. But anyhow, hopefully I've addressed this. Hopefully, maybe. I need more examples with pictures, I think. Anyhow, this is Tom from antiproton.com, anti-proton.com, breathing in some air. Breathing in my iodine for the day, getting my dose. Anyhow, bye-bye.